Hey guys, Mr. Backerberg here. In this video, we're going to take a look at even and odd trig functions. So just a quick reminder, remember graphically, even functions have y-axis symmetry, meaning that you can fold the graph along the y-axis and the points will match up, and odd functions have origin symmetry. So if we take our graph and rotate it around the origin 180 degrees, then all of our graph points will match up. So as we're looking at our trig functions, as far as even functions go, the cosine is even. If you look at taking this graph and folding it along the y-axis, the left and the right side mirror each other. And similarly, since the cosine is even, its reciprocal, the secant, is also even. As far as odd functions go, all of the other trig functions are odd. So if we look at this sine graph, if we were to take what's happening on this graph and rotate it 180 degrees around that origin, our points would match up. Same thing with the cosecant, the tangent, the cotangent. Those are all odd functions. So in this example, we're going to be confirming the even and oddness of the sine and cosine functions. So what I'm going to do is graph out a couple of angles in standard position. So this first angle that I'm going to graph out, I'm going to call that angle theta. And that's going to be a positive angle rotating in the counterclockwise direction. Now we don't know exactly where it's landing on our unit circle, but it's going to have just a general ordered pair x and y. Now the other angle that I'm going to graph out is going to be negative theta. So it's going to be the exact same size, but it's going to rotate in the clockwise direction instead. Now because these angles are the exact same size, there's a direct correlation between those ordered pairs. It's going to have the exact same x value, but the y values are going to be opposites of each other because we're rotating in that negative direction. So first let's talk about the sine, and let's look at the sine of positive theta first. Sine is the y value from the ordered pair, so in this case it's just y. But now let's compare that to the sine of negative theta. So if we look at that angle and its ordered pair, it's negative y. Now that just happens to be the opposite of the original sine value that we got when we looked at positive theta. And that's what makes this function odd. We defined odd functions as having this relationship with their function values. So we plugged in positive theta to the sine and I got positive y, but when we plugged in the opposite of that theta value, we got the opposite y value. That's what being an odd function means. Now let's talk about the cosine. So if we look at the cosine of theta, that's the x value from the ordered pair, which is just x. But then if we compare that to the cosine of negative theta, if we look at that ordered pair, that's also just x, which is the exact same as the cosine of positive theta. And that's how we defined an even function. If, when you plug in opposite values, you get the exact same answer, that makes your function even. Last example I want to look at in this video is using what we know about some trig values to help us find missing trig values. So here we're told that the sine of some angle theta is negative 3/5, and we're also told that the tangent of that same theta angle is less than 0, so it's a negative value. So I want to use these two pieces of information to first help me draw a picture, and then I'm going to use that picture to help me find all of my missing trig values. Because I'm told that the sine value is a negative value, sines deal with the y values, and y values are negative on the bottom below the x-axis. So we're either in the third or the fourth quadrant. This second piece of information is going to help us determine which of those quadrants we're in. As far as the tangent being negative, the tangent is negative in the second and fourth quadrant. So the overlap between those is going to be in the fourth quadrant. Now we always put theta right next to the origin. Thinking about right triangle trig, sine is opposite over hypotenuse. So the opposite side is going to be 3, the hypotenuse is going to be 5. That negative needs to go somewhere. The hypotenuse is never going to be negative. This 3, since it's coming down into the fourth quadrant, that's going to get the negative on it. Now if we look at our triangle, it's got a missing side. But we can use the Pythagorean theorem to help us figure out that that missing side would be 4. and because it's going to the right, it's going to be a positive 4. Now that I have my triangle drawn out, I can determine all of my trig values. So we already know that the sine of theta is negative 3/5. We can use our picture to determine the cosine of theta to be 4/5, since cosine is adjacent over hypotenuse. The tangent of theta, tangent is opposite over adjacent, so it's going to be negative 3/4. And then we've also got all of our reciprocal trig functions as well. So the cosecant of theta is the reciprocal of the sine, so that's 5 over negative 3. The secant of theta is the reciprocal of the cosine, so that's going to be 5/4. And the cotangent of theta is the reciprocal of the tangent, so that's going to be 4 over negative 3. That's going to be it for this video. Thanks for watching.